Hi everyone, this is a video on 6.2 logarithms in the Mhf4U1 course. Note that in chapter 6, you make sure you do your homework without a calculator. Your assessments will be no calculator. In this lesson, we will talk about the logarithmic function and how it's related to the exponential function that you have learned in your previous classes. So the log function is the inverse of the exponential function. In other words, if you remember, exponential function can be written in the form of y equals b to the power of x. And now when you find its inverse, you will switch the x and y values. So now in exponential form, that will look like x equals to b to the power of y. But mathematically, we also have a different way to write this function using the log symbol. So the form here on the left is interchangeable with the form on the right here saying y is equal to log x base b. So b is the base of the exponent, but now it's written as a subscript. So to think about how you can remember this new form of writing the log function, you can think of the log of the answer to the exponent to the exponential function with a little base and the exponents on the other side. So for example, if you see 5 to the power of 3 equals to 125, in log form, you're going to write log 125 base 5 is equal to the exponent 3. If you have 1/2 to the power of 2 equals to 1/4, think of it as log 1/4 base 1/2 is equal to the exponent 2. So here are some basic properties of logarithms. You can rewrite them in exponential form to solve for x. For instance, if I let x to be log 5 base 5, if I write this in exponential form, I'm going to get 5 to the power of x is equal to 5. So now 5 to the power of x equals to 5 is the same as 5 to the power of 1. If we compare these two exponents of the same base, then x must equal to 1. In other words, whenever I see log of b of base b, the answer will always be 1. The second property looks like this. If I have log 1 base 8 equals to x, then try to write this in exponential form. You have base 8 to the power of x equals to 1. Well, I can't compare 8 to the power of x to 1, but any power of 0, exponent 0, will give you 1. So I can rewrite the right side as 8 to the power of 0. So now I have 8 to the power of x equals 8 to the power of 0. So by comparing the two exponents, x must be 0. So when you have log 1 of any number as the base, you will always get 0. Next, we have log 3 to the power of 4 to base 3 equals to x. Write this in exponential form. 3 to the power of x is equal to 3 to the power of 4. Compare the exponents. X is equal to 4. So here we see that when I had log 3 to the power of 4 base 3, this is equal to 4. So if we generalize this, well, for any base, log b to the power of x base b will be equal to x. So you will be using these basic properties of log to simplify or evaluate some questions here. So log 16 base 2, you recognize that 16 is 2 to the power of 4. So the answer is 4. Another way to do this question is that you can let the original statement log 16 base 2 equals to x first, and then you can write this as 2 to the power of x equals to 16. and then you follow these steps to get the same answer, x equals to 4. So when you see log 1 over 49 base 7, this is the same as saying, well, 1 over 49 is 7 to the power of negative 2. So log of 7 to the power of negative 2 base 7 is negative 2. Here you have log 8 over 125 base 2 over 5. So you try to compare 8 over 125 to the base 2 over 5. 2 to the power of 3 is 8. 5 to the power of 3 is 125, which means that this fraction can be written as 2 over 5 to the power of 3. Now the bases match, so the answer is 3. Question D, log 1 base 6. Well, this is from the zero property, right? Whenever we have log of 1, no matter what the base is, you still get 0. E is just like the first 3 questions that we did. You already have 3 to the power of 8. So log 3 to the power of 8 base 3, that's just 8. And then in F, the base is 10, and you're trying to log 0.001. You may notice that this is just 1 over 1000. And 1 over 1000 is 10 to the power of negative 3. So the answer is negative 3. And you may notice that sometimes when we write log with a base. And there are times when the log is written without the base. When the base is not shown, it is understood that it is base 10. So if you use a scientific calculator to evaluate these common log of 0.001, you just find the log button on your calculator, and then you input 0.001 equals, that should give you negative 3. Likewise, if you have log of 305, punch that into the calculator, round it to 2 decimal places, that will give you 2.48. Example 3. We're going to solve log without a base 10 and rewrite in exponential form, and then use your calculator as a tool to approximate these solutions. In later lessons, you are actually going to learn a trick or another formula that will allow you to do this without guess and check. So let's take a look at log 10 base 2. We will let this equal to x, and so we can say that 2 to the power of x is equal to 10. Because we're doing guess and check, you need to find certain numbers that will give you a boundary. So I know that 2 to the power of 3 is 8, 2 to the power of 4 is 16, then x must be a number between 3 and 4, because 10 is between 8 and 16, and 10 is actually closer to 8. So when I use trial and error on my calculator, I will probably punch in 2 to the power of 3.1, 3.2, something like that, and see whether it gives me a number close to 10 or not. And it turns out x is approximately 3.3. So using a similar method, we can do that for log 100 base 3. So this can be written as 3 to the power of x equals 100. 3 to the power of 4 is 81. 3 to the power of 5 is 243. 100 is much closer to 81. It turns out x is about 4.2. And that's the end of lesson 6.2. So make sure you do your homework. For the property types of questions, like example 1, you should try to do them without a calculator. That's good practice for you.